This is the second video for laboratory work pick and place boxes, where we continue with the program writing and simulation testing. Now we are going to write the program for ABB robots for picking and placing the boxes. So now we have all our positions. Next step in here is to transfer all the positions to the rapid program writing environment. For that, we make a new path here. So we select paths and procedures, right click and create path. Then we can select all the commands here, motion commands, and drag and drop them to path 10. But I do recommend to make some changes. So let's change this speed, let's say to 500, and then increase the accuracy to maybe 5, which is more or less better actually. And now I select all the positions with shift and arrow keys and drag and drop them to path 10. And if I release, you can see all the positions I have here. The order, let's say, of the position is not important. Important is that I have all the necessary positions which I want to use in my program here located. And now I have to synchronize to rapid. So I go to synchronize, select synchronize to rapid. And the first time we should select all the components out here and then click on OK. Now the synchronize is done and we can go to rapid. Let's open the program writing environment and see if we have the positions or not. So here is the motion command itself together with the parameters, and then we have here these positions. So as you can see, everything is here as we need. So the first option for us to calculate the position is to use this function here, as you can see. So first we need to define a variable which we will use as the upper position, let's say, or the position where we transfer the calculated positions. We should never use the original positions, because if we use the original positions, then the calculation will change them, and in the next step when we run it again, the positions are not anymore correct, and we will not grip the object or place the object as we need. So we define this new variable, then we add the position for picking, and then we do this calculation here, which allows us to shift the position up. For the shifting, as you can see, we have this X, Y, and Z direction. In our case, we want to move it up. I would say that we need to use Z direction for upper part. How much? Maybe 100 millimeters or 150 millimeters. Sometimes you can use less than this variable here. And in the program, then we go and use it like here. You can see this motion command itself. Let's do then the calculation. First, we will create a new under program, or let's say routine. In our case, we can go with the proc and proc. It will be blue box like this. Then we go to up and define the variable. So here we need to var rob target, and we can write p underline up. Okay, like this, and we don't need to add any values in here at the moment. So now we go back here. I would take first this home position motion here, copy it and place it here. So home, I would use J motion because we don't know exactly in which direction the grip tool is oriented. So then we do the calculation. For that we have to add target 20 as its starting position. Then we need to move it up by some values. If I would not, let's say, add this upper position into the calculation as I'm doing at the moment, then it would just take the coordinates which I would write down here at the moment. So 0 is x direction, y direction is 0, and let's say 100 as z direction. So next what I will do is pick the box itself. So I can go here and select, let's say, this motion here. Place it here, not only once but several times, as this. I will change this part here, which is going to be up. The last one here is also changing accuracy to fine, because I want to place it correctly before I grip the box hit. Then I set the command to grip the box. I need to activate an output vacuum for it. Then I want to wait for the input activation, which shows me that the vacuum is active, like this. And if it works, then I need to move it up again. So I copy this line here and place it here. So this is for me to pick it up. I want to test it. For the testing, I'm not going to write at the moment place position code. Also necessary, what you need to do is actually have this calculation done here. Calculation. I'm also not going to write it. I will copy this target 30, place it here. Then I will copy this one here, which allows me to release it. So instead of set, I would use reset to release the box, and add then 0 here, which shows me that everything has been released. And in the end, I do need to move it home so that I can see if it's working or not. So I go up here, I take, let's say, these lines here and place it here. So this should be the final result. So this is my small program, which is missing at the moment some parts, but I want to test that if my calculation here is correct or not. If this is fine and it works, then I will copy this calculation, place it here, and then change the program here as I need. Okay, so and for testing, keep in mind that we need to release the box. Otherwise, if we do not release the box, then the simulation will not work very fine yet. What I'm missing is actually the blue box here. So add blue box in the main program, otherwise it will not be executed. So let's apply everything. Let's see, do we have any red markings? Nope, nothing red. Then I go to the simulation and let's reset the system to zero state. Sometimes I need to do it several times, the resetting. And now we can click on play and let's see how it works. Okay, okay, so it was very fast, as you can see. It took the box, it collided by gripping to the table, which is fine, but it did release too soon. So the box was released too early. To get that correct, I need to write here not 5, but I go with fine. So this will increase the accuracy for my case. Let's apply it. Let's see how the simulation works now when I have done that part. Is it going to be okay? Click it. Okay, go through and release it. Yeah. So as you could see, I went through the green and red box and then also the placeholder here. So this means that now I need to also do the upper position for the placing calculation and then the program fixing. But I can tell that the first part of my code for picking the blue box is working. And now let's make the other changes, or let's say you need to make the other changes as necessary. Another option for calculating upper position is the function called offs. So it's offset function, which allows us to offset in different direction. As you can see, the offset function is used here. We can use it together with the existing variable, or we can put it directly into the motion command. In general, when you put it directly in the motion command, it's much easier to control it. But also here we say which direction we will move it or shift the position. So we have this X direction, Y direction, and Z axis direction. And in our case, again, we need to use Z axis direction. And we will try to implement this offset function now on the green box. With the green box, I will actually use the blue box code as a base for my green box program. And because I'm very lazy, I will copy it. I will place it here and change it as necessary. So I will change the name here to green, then the home stays. The calculations I don't need, so I will remove this part here. Then the name here is not correct. I will use here offset command. Then target 40. This is the pickup position of the green box. Then I go X direction is 0, Y axis direction is also 0, and Z direction, let's say, with 100. Let's copy this line and place it as the line here also. So place it here. Then I need to change this one here because 20 is not correct. It should be 40. Placing position is going to be 50. And when it has placed it, then we go up home position again. So calculations don't need it. Let's remove it. So let's test it. I want to see if this offset function is working correctly or not. So let's go apply. Oh yeah, I'll change it. I will take off the blue box. I don't want to test it. I will add here this green box as I want. Apply. Let's go to simulation and see how it works. So reset the system first and now play. So it goes to the red box. Oh, I took the red one accidentally. Good. Okay, it was for red. So let's fix that program name. I didn't know that I took the red as the second one. Let's go to Rapid, change the name, red, and not this one, red. Apply. So we changed it. It should be fine. If I go to simulation, I go to reset the zero state. Let's put on play and see how it works. Yeah, so only part which is colliding on the table when the robot is picking up, which is fine. And when we place here, then it's colliding. So we need to fix the code again. Actually, you need to fix the code here so that it's actually moving up and down without colliding with the pallet itself. So I have written all the necessary code for the blue and red boxes. So I will now start the play of the simulation. So as you can see, I go up and down, I place it on there, no collisions. On the blue box the same, no collisions, only collisions with the pickup part. Here you can see that I have this corner path failure. Don't consider about it, this can be. As you can see, I changed the order of the placing. The reason is that if I did not, then the blue box, let's say the red box would have gone through the blue box and then I would have collision. So I can show you when I change it. I make the blue box as the first one, the red box as the second moving object. So let's see again how it works now. So here we have it. It goes, place it. It goes here, takes the red one, and you see it goes through the blue box. So that's why I changed the order of the box pickup and placing. Now what you need to do is, now you need to do also the program for the green one. So you have to decide which type of calculation or function you will use for it. So the last step is full simulation of the robot program, which we should have now created for picking and placing the blue, red, and green boxes. As you can see, the red and blue box have changed the positions, but doesn't matter. Important is that they're in the correct order. And what we also want to do is we actually will go activate now TCP monitoring, which allows us to see how the tool moves and acts in the system. Now I have written all the necessary code for picking and placing all the boxes. So let's see how it works. I go here, I click on the simulation play and see how it works. So first the red one, yeah, there was collision, but only one picking. Now the green one, and then the blue one. Again collision, but only one picking. Everything else worked fine. So what else I can do? I can use this TCP trace. This allows me to monitor how the tool setter point of the gripper is moving around in the space. So I will enable it. Instead of white color, I will use something else. Let's go with this one. Click OK. So this gives me exact motion of the gripper. So I go here, reset the system. Let's now click on play and let's see how it works. As you can see, it moves like this. Then the blue box we can see here, and then the blue one. Okay, the green one was first. So here you can see how the tool setter point on the gripper is moving, and it's doing its fine work. Next part, what we can do is I can use stopwatch to measure the time, how much it takes for the program to fulfill all the necessary motion. So here if you don't have anything, then let's click on add. Here we have the stopwatch, we can change the names. We have the simulation start and stop. Let's keep it like this. And let's go again, reset the system. Let's see how much it takes time to execute this one pick and place task for all 3 boxes. So again, we start it, we take it, we place it. Another one, pick it, place it, pick it, place it, done. So in general, you can see it took around 12 seconds, 12.2 seconds, let's say. Actually, it takes a little bit longer because the vacuum to generate it and then the release, it takes a little bit more time than here in the simulation. In real life, I would expect that it could take 5-6 seconds longer than here. But this gives you the best option, let's say, to see how much time it takes to execute the simulation itself on the Robot Studio. So this is the final part of our task, and as you can see, it worked fine. Okay, if you want to see, let's say, the code, how it's executed on the same time as simulation, then this is possible. We can go to Rapid, right click on the code here, so we select on vertical grouping like this. I will now make the code a little bit smaller so that I can see how exactly it is executed when I start the simulation. I can go to simulation here. I can reset the system again. Let's do it several times. Let's click on play. I don't see the code, so I go to Rapid, and now I see the code, and here I can see the lines which are executed. So if it stops somewhere, then you can see what each line is not working accurately. So, and that's it for today.